Now that we have all the data scraped and inserted into an SQL table, it is time to start writing queries to look at the data. Let's start with an easy one. Here is a query that returns the ticker symbol, the trade date, and the closing price, and it turns out that we want the most recent day in our data set. So our subquery has a select max trade date that gives us the most recent one. That's fed into the outer query, and then we list the ticker symbol, trade date, and closing price. Here is the query in SQL Server. Notice in the subquery we're getting the largest trade date, but we're doing it for each ticker symbol. So it's actually returning a list of the largest trade date for each ticker symbol, and it's fed to the outer query. Let's execute, and the latest date is the same for all the commodities, and that's July 21st. And so we can see the price of each of our commodities here. A daily return is a common finance calculation, and it's important, but we don't very often see that in SQL. So a daily return is calculated as today's closing price minus yesterday's closing price divided by yesterday's closing price. So here we see the formula, and we can calculate a return percentage. So we do a little bit of algebra and change it to be current day divided by yesterday minus 1, times that by 100 to calculate the return percentage. Here is the SQL query that calculates daily returns. If you'll notice, we have a window function, and it's the lag function. So we have the closing price divided by yesterday's closing price. We're partitioning by ticker symbol because we want to just see the returns for each ticker symbol, and we put it in trade date order. Here is the query then in SQL Server. Let's run it, and we'll notice that our first column is ticker symbol, and then we have trade date, and for each ticker symbol all of our trade dates are in ascending order. So for this ticker symbol, the closing price on the first day was 91.55, and the return was null because that's the very first record and it has nothing to compare it to. Day 2, the closing price was 89.38, and so as a percentage it went down by 2.37%. So in finance, we love to calculate daily returns as we try to build portfolios and do other items. The next query is going to utilize a table variable. Now, a table variable has a lot of advantages over other temporary type of tables. A table variable does not require locking and logging resources, nor are the variables or tables stored in the database. They execute faster than temporary tables, and indeed a table variable acts like a variable and exists just for a particular batch of query execution, after which it disappears. So here is the daily returns that we just calculated previously, but we're putting it into an SQL table variable. Let's look at that query then in SQL Server. There are 3 parts to this query. The first part is where we define the table variable. So we declared a table variable, and the name of that is @returns_table. We have 4 columns: ticker symbol, trade date, closing price, and the daily return. Next, we populate that table with data from the commodities table as well as a calculation for the daily return. After we've defined and populated, then we can just query the table to show that it worked. Let's go ahead, run this. We'll scroll this up so we can see our answer and see that we have our ticker symbol, trade date, closing price, and our daily return. That was returned from our table variable. The next query is going to deal with log returns. So hearkening back to middle school math, logarithms are used, and the finance profession loves log returns as opposed to simple returns. First, log returns are additive, meaning you can add log returns, but you can't add simple returns. You have to compound them. Also, simple return has a positive bias. So we calculate and analyze log returns to eliminate this bias. We are going to use two common table expressions in calculating log returns. So this first part, it says with CTE1 is our first common table expression, and that's where we calculate the daily return that you've seen before. The second CTE uses the results from the first CTE, but then we calculate a logarithm. Now notice here we're using the first CTE. Finally, in the bottom here, we do a select query. So let's go look at that in SQL Server. Here is the calculation then to do log returns. So the first CTE returns a ticker symbol, trade date, close price, and the daily return we've seen before. The second CTE here takes those daily returns, and again it's from this CTE1, and it applies the log function. So then that's calculated. Finally, we query the second CTE, and let's look at the results here. And we can see the ticker symbol, the closing price, the trade date, and this time it's the log return and not just a simple return. Another calculation that we want to often make is standard deviation. Now we can look at the standard deviation for the given commodity, but it might be more useful to look at the standard deviation over 30 days, meaning the past 30 days. So here's a query that calculates the standard deviation for each commodity for 30 days. Let's go to SQL Server. Let's execute. And let's look at this last one here is the Chicago wheat. And notice here we've got standard deviations $38, $38, $37, and then it drops down to $19, $17, $15. So we can see how the prices are moving and the standard deviation with this query. Now looking at it, we calculate the standard deviation here. We're also creating a partition for each ticker symbol, and the one thing that we haven't seen before is this, and this is what allows me to go 30 rows previous to the current row to calculate standard deviation. To refresh our memory, let's do a select star from Commodities and look at the table as it exists. Notice that we have the commodity name right here, then we have the ticker symbol, the trade date, and the opening price. What would we have to do to have each commodity be its own column title? We would have to rotate a table. Now I know this is small, but we have trade date, and then we have the closing price for each of the commodities. Crude oil, gold, lean hogs, and so forth. So, how do we rotate a table? The answer to that question is that we rotate a table by using a set of correlated subqueries. So, to look at the query, we select the trade date, and then we have a correlated subquery. And so we have select closing price from commodities, and then the key here is the where condition. So we're looking to set equal the trade date to the trade date in our subquery, where it's equal to our ticker symbol, and the one we want here first is crude oil. I repeat this subquery for every commodity. The end of the query looks like this. We have the last subquery for Chicago wheat. Then I say from commodities as C, and then I order by the trade date. Here is the query in SQL Server. Notice this is our outer query, and then I have a series of 10 subqueries, one for each commodity. Notice I delimit each subquery with a comma right here, so it becomes its own column. Now here at the bottom, I have in my outer query from commodities as C. So C is the alias. So every one of the subqueries, I'm selecting the trade date having to be equal to the outer queries or the C.trade date. So that's what makes it a correlated subquery. So I have from commodities as C, and then my very last thing is I order my answer set by trade date. Let's run it and bring this up so we can see, and notice that we have trade date crude oil, gold, lean hogs, lumber, cattle, orange juice, platinum, sugar, soybeans, and Chicago wheat. So I really like this example because it shows how to rotate a table given the values in a single column. I've saved the results of the last query we did in SQL into a .csv file. And here I've named it commodityprices.csv. So I'll run this window, and then we will read the data into a data frame. We'll look at the shape, which means there's 26,269 rows and 11 columns. Here's a listing of the columns, and here is the first 5 rows. So we have trade date, crude oil, gold, lean hogs, and so forth. So let's do a describe, and we'll see how many, what the mean, the standard deviation of each of the prices of our 10 commodities. Next, we are going to build a correlation matrix of our 10 commodities and then feed the correlation matrix data into a heat map. So let me run this. Usually takes a second to come up, and we can see both the correlation and we put it into a heat map. So we say, oh well, this diagonal always has a 1 in red because the price of crude oil is correlated perfect to the price of crude oil. So you always get that in a correlation matrix. But something that's more highly correlated is an orange, and something that's inversely correlated here is a purple. The way then that we've got our correlation statistic here in the box is we chose this option, annotation equals true. So we also did a color scheme called rainbow. I like that color because it's pretty vibrant. So we calculate a correlation matrix and then we make a heat map. A heat map is an excellent way to communicate the idea of a correlation between variables. A lot of people like to look at those, and they convey a lot of information. The next thing we want to do is regression analysis. Now this is very common in data analytics. It's one of the most important things we do when we look at different variables and if one causes the other. So in this first frame we drop the null values. we are going to use gold as our independent variable and crude oil as our dependent variable. So I set X equal to the gold column prices. I set Y equal to crude oil prices. I'm going to run this frame, then this frame, and let's run this one. And let's go look at the output. It turns out that gold is a very poor predictor of oil prices because our R-squared statistic is 0.026. So that's not very good at all in determining the price of oil. So let's go and run the same thing now with gold and platinum. We'll look at the statistics and note that this is 0.098, so that's a little bit better, but that's not very good at predicting the price of platinum either. So those are a couple of examples of running regression analysis. Python makes it very easy once you understand the language and can set up the syntax correctly. Once we've done our regression analysis, it might be nice to look at all of our prices and have them on a plot chart of some type. So here's a way to do that. Here's my data frame trade date here that I'm going to use for every plot, and then I have the crude oil prices, the gold prices, and remember these are the column titles or the titles that you're going to have at the top and that we're going to grab to plot. So let's run this. Let's look at the chart here, and we see our lines all over the place, but it should be coming up to a problem in your mind because one, we have some prices up here that are up in the 2000s, and this one here is gold, and then we might have platinum, but then we have soybeans, and it just doesn't seem right to us that those prices are anywhere near each other. Let's go ahead and look at our commodities table here, and maybe that'll help us see why we shouldn't put all these commodities on the same chart. So first, let's look at crude oil. Those contracts are measured in US dollars per barrel. Now, as an aside, each contract is 1,000 barrels. But let's go down this list of descriptions. Gold is also in dollars, and this is in by troy ounce. But when we get to lean hogs, it's pennies per pound. And random lumber futures are pennies per 1,000 board feet. Live cattle, pennies per pound. Orange juice, pennies per pound. Platinum, though, is dollars per troy ounce. Sugar is cents per pound. Soybeans, cents per bushel. And Chicago wheat is also cents per bushel. So it makes sense that we should put anything measured in dollars maybe on one chart and anything measured in pennies on another chart. It makes sense then to put oil, gold, and platinum on one chart and then the other commodities on a separate chart. So when we look at this, we see PLT, and if we remember from the beginning, that is a shortened nickname for matplotlib. So these are some simple charts. We can certainly do more extensive ones, but let's look at the chart that shows gold, platinum, and crude oil. Now I still might do a separate one than this because the distances between prices is so far, but at least we're all measuring in the same unit, which is US dollars. So we see the platinum is the green line, and we see gold is the orange. We see crude oil typically going somewhere as low as maybe $20, $30 a barrel, all the way up to $100, $150 a barrel. So here is our second chart that has the other 7 commodities on it. Let's run it, and we'll note that we have lean hogs, lumber, cattle, sugar, soybeans, Chicago wheat here, plotted by trade date. And these are all on this chart because they're measured in pennies per unit. Let's look at the chart and note that we have soybeans that go for many pennies per bushel, all the way to Chicago wheat, something else that's way down the list. So I might even change the chart to be maybe logarithmic, or I would have separate charts for some of these commodities so that we don't have such wide data variance here.